Good morning. This topic explains analysis and implementations of active noise control strategies using piezo actuator. This is a summarized uh, topic explained with a right. The authors are shown from Peru in Germany. Index objective introductions, state-of-the-art active noise control, where we explain the simulations and experimental results and conclusions. And finally, suggestion to discuss. Objectives: analyze setups to experimental test because it's necessary to know the physical parameters in order to the, develop experimental algorithms and simulations algorithms. Achieve range of work for piezoelectric actuator loudspeaker. Design algorithms and strategies of active noise control ventilation systems. Introductions: noise pollution caused by systems transportations that is typical in some countries and cities, like for example, noisy taxis in Lima. Noisy caused by airflows structures because of incorporating work. They are really noisy motors, engines, which are part of ventilation system, produce high levels in noise, and this is not comfortable for people who works in or works or live inside buildings which has a ventilation system. It is possible to evacuate heating by convections. Nevertheless, the noise is nothing comfortable. This is a good example. The aircraft engines produce noise, high level noise, that can be hearing in surface. Nevertheless, what happens for people who are inside the cabin, because of they can perceive these high levels of noise. The explanation is in cabins is isolated by material which absorb this noise. But sometimes in high frequency of noise, through this cabin and through these material absorber materials, and suddenly is produced anti-noise signals which target to reduce and cancel this noise. That is explained like an active noise control. Because of, as for example, for intelligent headphones, external noise is cancelled by anti-noise signal, which has the opposite amplitude in order to eliminate this noise. But in case in which can be deleted or rejected noise or reduced noise with absorbed material is named passive noise control. If we create an anti-noise signal, it's named active noise control. State of the art can be summarized as follows: ventilation systems in order to create anti-noise signals to reduce noise produced by fans. Transport system, because of, for example, modern cars has the ability to produce anti-noise signals to delete external noise. Headphones was shown in last slide, and mines, because of workers are near big motors that are really noisy, and it's necessary to take care hearing healthy conditions by active noise controls. And communication system, because good applications by smartphones and modern phones produced by programming with active noise control. State of the art, the figure shows prototype designed by Mr. Technukin. Here is emitted the primary signal, and that is sensed by these microphones, and these error microphones give information from the difference between the input signal and the anti-noise signals. Desired value should be null. And active noise control. Many authors worked with this theory and topics, and for example, Guo and Morgans. Before to get the control algorithm, it's necessary analyze adaptive coefficients, which is achieved by the difference between the input signal through the transfer function of the plants and this error coming from the difference from this signal, which is obtained by the adjustment coefficients from this filter, adaptive filter. This process is named identifications parameters. With these identified parameters, it's possible to design and control adaptive algorithms. It's known the transfer function for the plant, and it's possible to estimate the signal and adjust this filter with the difference between the input signal and the estimated signal. Secondary path go to get the error and going back to adjust the coefficients. And it's possible to get an equations in order to explain the last behavior. The error is equal to the primary path transfer function minus the secondary, this is knowledge, like a response of the secondary path, and the coefficients multiplied by the input signal. The error is knowledge like the desired signal minus the response, and the single response, the convolutions between the transpose of the coefficients with the input signals and the cost function eta. Notwithstanding, sometimes the secondary path is unstable because of high levels of noise in low frequency produce these instabilities. For the reasons, the constant function should be changed. Independence of these constants gamma and with the components of the coefficients of the filter. And the relations are given by the following equations. That's knowledge like FX-LMS algorithm with leakage. Active noise control by feed-forward algorithm is shown in this figure because of estimated signal, adjust the coefficients in order to create estimated signal and reduce this input signal, evaluating the error. Feedback algorithm has the characteristic to use only one microphone to measure the error signal. It's not necessary to know the transfer function for the plant because of the input signal is estimated in order to work with the estimated secondary path and set the estimated signal. And the hybrid algorithm has the characteristic to work with two behaviors, the feedback and feed-forward algorithm. It's not so faster like feed-forward, and it's not so it has not so strong rejection for disturbance like feedback, but has an average behavior. Well, that will be continued in the next video, please. Thank you.